Hello and greetings to everyone. We are to answer the following questions. For question 1, the length L of a rectangular garden is 2 times the width W. Question E, write down an equation in L and W. We take solution. First, we are going to start by drawing the rectangular garden. You know, a rectangle is a plane figure which has 4 sides with 4 interior angles, with each of the interior angles being equal to 90 degrees. And the opposite sides of a rectangle are equal. They are equal and parallel. Let's assume this is the rectangular garden. These are the interior angles. Each of them is equal to 90 degrees. And this is the length. The longer side is the length, while the shorter side is the width. We have been told that the length of the garden is 2 times the width. Question A is asking us to write down an equation in L and W, that is in the length and the width. We know the length is equal to 2 times the width. That means you take the width plus the width, and this will give us the length to be equal to the width plus the width gives us 2 times the width. So this is the equation of L and W. We are done with the first one. Go to question B. Question B says write down an expression for the perimeter in terms of L and W. The perimeter, when you talk of perimeter, it is simply the distance round the rectangular garden. The perimeter is simply equal to, we start here, we are going to take this length plus width plus length plus width. And this will simply be equal to length plus length gives us 2 length plus width gives us 2 width. This will simply be equal to 2 times, you see that 2 is common, 2 times the length plus the width. This is an expression of the perimeter in terms of L and W. Underline the result. We go now to question C. Given that the perimeter is 30 meters, perimeter is equal to 30 meters, the distance round the garden. Question C is asking us find the values of L and W. From question B, we know the perimeter is equal to 2 times the length plus the width. And this is simply equal to 2 times, from question A, we know the length is 2 times the width. So we are going to replace L with 2W plus W. This will simply be equal to 2 times 2W plus W gives us 3W. And this will be equal to 2 times 3 gives us 6. We attach W. So the perimeter is simply equal to 6W. Now, for us to find the length and the width, we are going to equate the perimeter 6W to 30 meters. We are going to equate 6W to 30 meters. Then If we divide both sides by 6, this will be equal to 30 meters divided by 6. And this will give us W to be equal to 30 meters divided by 6 is equal to 5 meters. The width is 5 meters. Now we can find the length. The length will simply be equal to, we know the length is 2 times the width. 2 times 5 meters, which is simply equal to 10 meters. So this is the width. Go now to question D. It says write down an expression for the area of the garden in terms of L and W. D. First, we know the area of a rectangle is given by the length times the width. This gives us the area of a rectangle. So the area A is simply equal to LW. So this is an expression of the area of the rectangular garden in terms of L and W. We know that L is equal to 2W. If we replace L with 2W, then A will simply be equal to 2W times W, which is simply equal to 2W times W gives us W squared. This is what we are going to obtain. Now we go to the next part of the question. It says that given that the area of the garden is 72 meters squared, find the values of L and W in this case. That's a question E. We have been given that the area is equal to 72 meters squared. We have to find L and W. First, we are going to start by equating 2W squared to 72 meters squared so that we can find the width. 2W squared equal to 72 meters squared. We are going to divide both sides by 2. This will be equal to 72 meters squared divided by 2. 2 will cancel 2. We'll be left with W squared equal to 36 meters squared. Then take square root on both sides. This will equal to the square root of 36 meters squared. Then the square root of W squared simply gives us W is equal to the square root of 36 meters squared, which gives us plus or minus 6. In this case, we are calculating the width, which is distance. And we know distance can never be negative. So in this case, we are going to take only the positive square root. And this will give us W to be equal to 6 meters. Knowing the value of W, we can calculate L. We know L is equal to 2 times W. So this will give us 2 times 6 meters, which is simply equal to 2 times 6 gives 12. This will give us 12 meters. Therefore, the width is 6 meters in this case, and the length is 12 meters. We go now to question 2. Question 2 says solve the following inequalities and represent the solution on the real number line. For question 2a, we have 4 minus 3x is less than 13. For us to solve this inequality, we are going to apply the same steps in solving an equation, except for the fact that if we are to divide both sides by a negative number, the inequality sign reverses. Or if we are to multiply both sides by a negative number, the inequality sign reverses. In this case, we are going to keep negative 3x at the left hand side. Negative 3x will be less than, we are going to transfer 4 to the right, less than 13. When 4 crosses the inequality sign, it becomes -4. This will give us -3x is less than 13 minus 4, which is 9. Next, we are going to divide both sides by the coefficient of x, which is -3. -3x divided by -3. Since we are dividing all through by negative number, the inequality sign reverses. So instead of less than, it changes now to greater than. It's greater than 9 divided by -3. -3 will strike off -3. We'll be left with x is greater than 9 divided by -3 gives us -3. X is greater than -3. We are going to conclude, therefore, x greater than -3 is the same as saying -3 is less than x. Therefore, x greater than -3 is the solution. Now we are required to represent the solution x greater than -3 on a number line. We're going to start by drawing our number line, which carries the critical value -3. At the critical value -3, we are going to draw a ring like this. X is strictly greater than -3. Since it is strictly greater than, the ring will be open. That means -3 is not part of the solution. The values greater than -3 are to the right hand side of -3. -3 is greater than -3. -1, 0, 1, 2, and so on. -1.5 is greater than -3. A half is greater than -3. So all the values greater than -3, they are to the right hand side of -3. We are going to indicate it like this. Since the values are infinite, that means they continue. We are going to put an arrow like this, indicating that the values continue. Then we are going to write down the solution above this line, this horizontal line. X is greater than -3. We shed these portions like this, indicating that this is the solution. So this is how we represent the solution x greater than -3 on a number line. We move now to the next question, question B. For question B, we have a double inequality, 3 less than or equal to 2x plus 1 is less than or equal to 3. For us to answer this problem, what we are going to do is we are going to add -1 throughout this double inequality. This will give us a -3 minus 1 is less than or equal to 2x plus 1 minus 1 is less than or equal to 3 minus 1. The reason why we are adding -1 throughout this inequality is because we want to eliminate 1 from 2x. We want to eliminate this constant 1. So that we'll be left only with 2x. -3 minus 1 gives us -4 is less than or equal to 2x. We know 1 minus 1 gives 0 is less than or equal to 3 minus 1, which is 2. The next step, we are going to divide all through by 2, the coefficient of x. Dividing all through by 2, -4 over 2 is less than or equal to 2x divided by 2, which is less than or equal to 2 divided by 2. Negative 4 divided by 2 gives us negative 2 is less than or equal to 2x divided by 2 gives us x is less than or equal to 2 divided by 2, which gives us 1. Negative 2 is less than or equal to x is less than or equal to 1 is the solution of the given inequation. Conclude therefore negative 2 less than or equal to x less than or equal to 1 is the required solution. It simply means if we take any value of x that lies between negative 2 and 1 inclusively, the given inequality will be verified, will be true. Now let's represent the solution on a number line. Let's draw a number line. In this case, the boundary values are negative 2 and 1, something as such. So we have something like this. Then at the boundary values, we have negative 2. This is negative 2. Negative 2 is less than or equal to x. That means negative 2 is part of the solutions. The ring will be shaded like this. We go now to the next boundary value, which is 1. X is less than or equal to 1. That means 1 is part of the solution. So at 1, the ring is shaded too. But we are going to shed the values in between negative 2 and 1 because they are part of the solutions. So this required zone. Shed this portion like this. Then we write above negative 2 is less than or equal to x is less than or equal to 1. Negative 2 less than or equal to x less than or equal to 1 is the required range of values of x for which negative 3 is less than or equal to 2x plus 1 is less than or equal to 3. We can verify to see if this is correct. If, for example, we take x to be, let's take 0, this will give us negative 3 is less than or equal to 2 times 0 is 0 plus 1, 1 is less than or equal to 3. You'll see it is true. If we take x to be negative 1, it will still be true. Let's verify. This will give us negative 3 is less than or equal to 2 times negative 1 gives negative 2. Negative 2 plus 1 gives negative 1 is less than or equal to 3, which is true. We are done with the solutions. If in case you have any problems, you leave your questions at the comment section. Please like the video, share and subscribe to this channel. Thank you very much for watching.